I don't know. I wanted to make some poem there, but it did not happen. So this is 2022 set to 2 marks. Can we solve this, students? Consider steady state one-dimensional heat conduction in an infinite slab of thickness 12 as shown in the figure. The conductivity K of the material varies as K is equal to C into T. It varies with the temperature, where T is the temperature in Kelvin and C is a constant equal to 2 watt per meter per Kelvin square. There is uniform heat generation in the slab. If both the faces of the slab are maintained at 600 Kelvin, the temperature at X is equal to 0 is. That is the maximum temperature they have lost. Now here there will be people who will be directly putting the formula which we have got and will go miserably wrong. Always go with directly with the heat conduction equation. What is it? D square T by dx square is equal to plus qg by k is equal to 0. Now integrate that. That's how you have to do. Don't remember the formula. If you remember, it's fine. But see, when you remember, you see where it is. See, in those formulas, k has been taken as constant. Here, k varies with the temperature. You see why it was difficult this time? Because the approach is formula remembrance and getting the answers. Substitution. The people with substitution got wrong this time. Same thing, is it not? It's nothing else. Put it and get it. So this equation. So let us solve it. D square t by dx square plus q generation by k is equal to 0. This is the heat conduction equation which is applicable, is it not? So do that. L is equal to 1 meter is given. So put the boundary condition, get the answers like that. So what you will have, this one has, you will have d square t by dx square, correct, into k. K is what? C into t, right, is equal to minus qg. Yes or no? Or we could set this one as minus qg by ct. Then what happens? dt by dx, dt by dx is equal to minus qg by c log of t. Getting the point? Plus c1. So you have to find the c1. How do you find the c1? Sorry. Into x. Very sorry. That's a mistake. Then t is equal to minus qg by ct into x square by 2 plus. Huh? T we can take left. It's a constant. Oh, no, 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 no. This is wrong. This is wrong. This is totally wrong. D square t by dx square. T d square t by dx square is equal to minus q by c. Fine. Now, while integrating, what can we do here? T into d square t by dx square. We cannot take t as a constant. Not easy. This is one of the tough questions. What should happen here? Now, t into dt by dx. So here, t into dt by dx. Can you write this as equal? Or if you see, okay, d by, what is d square by dx? dt square by dx. What is that? It is equal to 2t dt by dx, correct? Agreed. 2t dx dt by dx, is it not? Yes or no? Okay, so now, just a second, student. This has to go inside, that's it. How do you take it inside is the question. How do you take it inside is the question. So here it is, once. Integration is a challenge. How do you integrate? 2t dt, is it not? Or we can say dt square by dx square and square. Can I write it as 2 times t into d square t by dx square? Can I see that? No? Or dx by dt? No. One second, one second. No, 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 no. Just a minute. There is some corrections which you can do. T is a. Oh, let us do one way. We'll write it this way. Okay, we'll write it this way. This is variable separation, so we can do it. It is variable separation, is it not? You're getting the point? No. Let us see. Second order. Ah, yeah, that is the best. What should we do here in your opinion? It's a second order. That's what you're saying. No, 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 not it. It is not a the second order, no doubt. Okay. So it is a non-linear, is it not? It is non-linear, is it not? Is it a linear differential equation? No, it is not. It is like saying d square y by dx square minus 1 by y is a non-linear, not a linear. That is linear solution what you're doing. So you cannot solve it like that. This is a non-linear differential equation. Okay. So now how do we solve it? Let us see. K is varying as t, is it not? Wait. One second, one second. This one can be solved in this fashion only. Okay. So dt square by dx square is equal to 2 times dt by dx, is it not? Can I write it that like that? Yes or no? This is correct. Yes or no, Sharon? Correct. Okay. Now, if I write d square t square by dx square, will it be equal to 2t into d square t by dx square? Yes or no? No? Yes. Can I write it like this? You have to differentiate this. Correct? Agreed. Nihal, I want, is this okay? Or do we have some trouble there? See, you have to differentiate twice. It is it is a way of having a chain rule, is it not? So let us have this as the equation. We will write it as d, d square t square divided by dx square. I'll write it in the next step. So let us write this as d, d square t square by tx square. If you're writing, write it pencil only, minus q by c. Or we will write d t square by dx is equal to minus q by c into x, or t square is equal to minus q by c x square by 2 plus, this is c1, plus c1x plus c2. Now you have to apply the equations. Applying at x is equal to L, which is equal to 1 meter, T is equal to 600 Kelvin. Correct? It is given in that it is 600 Kelvin. Yes or no? Okay, let me try it out. Okay. So now when you put that, T square is 600 square is equal to minus Q. Q generation is given, is it not? 1280. So 1280 by C into x square, that is 1 square by 2, plus C1, or we'll use L. We'll use notations only so that we'll get this is, say, T1 and 2 they have given, is it not? This is x is equal to n. This we will say it is 1, and let us say this is what two things we'll write and we will get it. So x is equal to, at x is equal to x1 is equal to L, we'll get it as T, हाँ एक मिनट आएगा, T1 square, apply that and find C1 and C2. Chalo, done. So T1, did you get C1 and C2? So t1 square is equal to, we have put it as 2, is it not? T2 square is equal to minus q by c L square by 2 plus C1L plus C2. How will you differentiate? How will you differentiate this? T is an independent variable. X is sorry. T is a dependent variable depending on x. T is a function of x alone. Correct. Yes or no? Not convinced. We cannot write it like this. Then what should we write? When this is valid, why this is not valid? This is not connected. This is different. This is different. Not connected. Don't connect these two. If I differentiate, double differentiate t square, okay, suppose in case I'm not differentiating the first one. No, no, no. Okay, leave this. Leave this. Not required. Not required. Wait a minute. I got the confusion. This one. I am just telling you. I'm just telling you. How will you write d square t square by dx square? Okay, fine. See here. D of any function of x by dx square. What is this? What is this? Or square. I'm square. df dfx square. What is that? Okay, right. Let me write it. D of dx of oh, correct. Right. And that's a mistake. Okay. So what you get if you write d t square by dx square. Wait a minute. Dx square. So that the next one is wrong. Okay. So this one will come as d of dx of dt square by dx. Correct. So this you are correct. This will become as d of dx of 2t dt by dx. That is nothing but 2 times d square t by dx. 2 times d dt by dx plus d square 2t d square t by dx, right? So now this if it is there, now what do we need? D square t by dx square, t into d square t by dx square. Huh? This one, this term, which is whole square. Ah, 2 times. So now, you're correct. Okay, dt by dx whole square we have here. We go with these complications is one thing which I've asked. Let us see. So we need 2 times. We need t into d square t by dx square. So what I'll have is we will have d square t by dx square 2t. Good that our Sujit is not there. 2t square is equal to. Now this will be d square t square by what do we need? T square t. Okay. Which one? This is proper, right? This is proper, right? This is proper, right? So now I need this term basically, or this term basically. Both the sides I'll multiply 2. Okay, then see what my purpose is. See, have got a term which is t into d square, t by dx. Square can be calculated. Square. Second order is not a trouble. Trouble. We should not get non-linear. That's it. This is not second order. This is second degree. Second order is not a trouble, but this degree being a mistake problem here.
Sir,
Ah, yes.
I have done some things. I have sent you in WhatsApp. Can you please check it out?
You have done in another method, is it?
No, it's the same. But the thing, I'm getting the same answer, but whatever you got in the next slide.
This is it. Wait a minute. Okay, let us do in this fashion. Okay. See, one of the main thing is that d square t by dx square is equal to, wait a minute, sir, q into c t. Correct? Now, what we can do is we can write this is d by dx of dt by dx. How can you take dx just like that is equal to minus q by, or we can write, observe, yeah, minus q by c here, t, right? So let this t go here. So we'll write d by dt by dx is equal to, let us have minus q by c dx. Now when you integrate, you cannot write, you have to write integration of this. No, you cannot do that.
Sir, why, sir? You can, no? I mean,
Okay, you're right.
if you write dt by dx, you can take the dx other side, no? Similarly, it is d of
Now
something
when
by,
you integrate, you cannot write t dt.
I mean, it is a d of something. For example, d of a function, integration of d of a function is nothing but a function plus a constant.
See here, this is d of a function. Okay, d of a function, and here you have the function. So you cannot do that.
But you're differentiating with respect to that function, no, dt by dx. I mean, integrating
But
with
if
respect to
there's
dt by dx.
t is not a constant, no. T is a constant, then you can do it. If it is not a constant, can we use UV rule? Is the question. Here, this is till here it's proper. Huh? I'll tell you. Integration of u dv is equal to uv plus integration of v du. Yeah, he says yes. That is not correct. His thing is like this. He says this. Take the WhatsApp. What he's saying is this. You cannot do that. He's taking from here d of dx, qg dx. He's integrating to this. I'm having a problem with going from here to here. Not correct. This d he took it this side. Here, this one. Yes, he cannot do that. That's what I'm saying. Okay. So it is not proper, is it not? So let us do this UV rule. So this is u dv. Fine. So this u is here t, v is dt by dx. V is dt by dx. You're differentiating that. Okay. Both the same, but it's not the same function. Come on, u and v, y square and 2y are different functions. Y square. Let us understand. I think this will come down. That is just see that thing which is there, which is what is that called? Huh? Islet is just this one, but that is applicable everywhere. UV rule is applicable everywhere, not only for logarithm. That is just a way to say you can apply it just like that. Okay, so you doing this. Let us see. Let us see. Let us see. So U is t. So U
Sir,
into or t. One
sir, I
second.
think there is minus in between. It's not plus.
Which
The
minus?
rule. It's UV minus integration of V.
UV into minus. Sorry, that's correct. UV minus integration of Vdu. Correct. So here dt by dx. Observe UV minus integration of V. V is what? Dt by dx. What is u? Du. It's 1. Observe here, observe here, observe here. It is coming down. 1 du, 1 dx. Makes sense? Hello? You can take t inside. How? I cannot. You can't. You can't take t inside. Okay. So that's why we are doing all this circus. Okay. T into dt by dx. This is u. This is v. Correct. So u. When? What did I say? What did I do? We will see that. Look at it and tell me that. You can't take it inside like that. Point me out. Okay, if it is wrong, will correct it. Okay. So T. Huh? No, no. That is one particular. This is what I tried to do here. You see, this is proper. This is proper. See, what did I do there? I will tell you. T into dt by dx. I changed it to 1 by 2 d of t square by dx. I'm okay with it. If I use u into du by dx, this can be written as half into du square by dx. Because when you take outside, you get 2 times u, is it not? 2 cancels. This I might have used. This is called conservative form of Navier-Stokes equation. We took energy form. That is important. This relates to energy. This we use in turbulence a lot. I did it in turbulence only, yes. So we do this in turbulence a lot. When we have to write, especially when we have to derive the K epsilon formula. I have not done that to you. Okay, I have not done that. But yeah, so let us see. So here this is okay. It's good. When we do this, we will get the idea of this, is it not? So t into dt by dx minus integration of dt by dx into dx, right? Correct? Hello. Okay. Is equal to here minus q by c into x plus c1. Now this dx can cancel, and we can get dt by dx minus ust. Yes. No, I did not write that. Okay. You will get dt by dx. Correct? Okay. So you will get 1 by dt by dx, integration of dt by dx, the whole square. I took v as dt by dx. It is not this complicated. It is not this complicated, let me tell you. If you get into these complications, keep in mind you have missed some concepts. Okay. Uh, because there is t square coming, is it not? T into dt. Yeah. Non-linear one. Okay. Let us see, is there something which we have left? A is equal to. Ah. So you get dk by dx. Do it. You try it out. I will try it out by then. Okay. You try it out different methods, whatever you can, students. We'll get the answer. Don't worry. It's because we are stuck somewhere. Okay. We'll do it well. something simple. Sometimes we get stuck. See, one of the main thing here is this. I'll tell you. In my opinion, that's how it works. Cannot. It cannot. Sorry. Because when you integrate, only we'll get it. Is it not? No. There is some simple things which we have missed, students. We have to integrate. Integration itself is becoming difficult here. Integration of t into d square t by dx square, which is non-linear. Let us look at some of the integration methods. Go back and let us take some of the simple differential equations if we miss. You got the answer, mister? No, right? First order. No, this is second order. No, this is second order nonlinear. Solving is not feasible. Solving is not feasible here. What's the answer you got? 1000? Huh? But you'll get to know only when you integrate, is it not? If you can't integrate, then what will you do? And there is generation also, so you cannot take just heat conduction. We can do one thing. We can do one thing. The heat generated equals heat conducted. Can we use that? Let us try it out. Just thought. Okay. Yes or no? Heat generated is equal to heat conducted. Correct. Can we use that and find the answer? Heat generated we can know, is it not? Here is my pen. So let us do heat generated is equal to heat conducted. Correct. What is the heat generated per unit width? Heat generated. Heat generated is equal to per unit thickness here. Let us take 1 here. Right? Heat generated is equal to and 1 area. Let us take area as this is 2L and 1 there, and let us take this as 1. So heat generated is equal to Qg into 2L into 1 into 1 per unit length. Okay, that should be equal to heat conducted. Heat conducted Q is actually equal to, no, it is not from the same place. It's not from the same place. That's the problem. Huh? And here, if I say, in case I say, but K varies. K is not the same. Hmm. Heat conducted from here to here is not the same heat conducted here from here. No, it's the same because it's in series. Heat conducted remains same. Yes. No, 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 no. Heat conducted does not remain same. I'm sorry. Heat is generated here. Heat is generated here. It is not the same. Which one? You're taking this. This one. Okay. Huh. Oh, yeah, 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 yeah. Correct, correct, correct. 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 Okay. Yes, we'll try. We'll try. Good. Good idea. See here, the question is, we have got this, is it not? So from this, we can always write. Our purpose is to get a dt square t by dx square. Fine. So this would be equal to this would be equal to. I can write. Okay. This divided by 2. So you'll get 1 by 2 d square t square by dx square. Okay. Plus dt by dx, the whole square minus this. Now dt by dx at the center is 0, is it not? Dt by dx at the center is 0. So at x is equal to 0, we get t d square t by dx square is equal to sorry, at x is equal to 0, half into d square t by dx square. Okay, so now this we will substitute here and integrate. Integration, what is the purpose to find? What is the purpose to integrate? What is the purpose after integration? You get only near the center. Huh? Exactly. Now this integration, if you do it like that, it is applicable everywhere. But this is applicable only here. What is the temperature based on what is the site temperatures? We cannot get the plot. We cannot get the plot. So this non-linear differential equation we have to solve. I'll tell you tomorrow, students. I'll think about it. Any other things you have? No, no, no. That is not the way. It's challenging. Numerically you can solve, but not numerically. You should not go numerically. It's some simple concept which you have missed. Simple and it does not become complicated like this. Okay. Another way, let us try. Okay. See here, we have used one more try. Okay. See, we have used this particular one. You see here, QG, not this, not cylindrical. Let us try out this and let us see where we'll get the answer. Theta wall is equal to QGB by 2H. It is not proper. It's not proper. I'm not saying 100% proper, but let us try. Okay. So if I use that, see at x is equal to b by 2, that is this one, QG. Okay. So if you have theta w is QGB by 2H, let us use it. Oh, H is not. Theta wall. No, you cannot use it. Let us use this T max is equal to Q is equal to. That's correct. So what is that? How do you get that? You will get it. I am not saying you will not get that, but you'll get only at the one end. See here, one of the way we can do is, yes, you can write Q is equal to K dt by dx. Now tell me how you proceed. What is Q? Q you can write the heat generated, total heat generated. No, K will vary with the temperature because temperature varies there. No, because T is a function of X. If that was there, I could have done integration here. No, that's what I was worried about. 1 by y of x dx. What is the integration? Struggle. Okay. Yeah, we'll take it like that only, but how will you integrate? Oh, let us do that. Let us Yeah, correct. What he's saying is this one, what is there, we will substitute that. This will substitute into this equation, and we will keep the integration just like that. Let us look at it after that. Okay. At the center it will be 0. At the end, good, top notch. I got it. So now, very difficult thing this is. Okay. In gate, if you come, ignore. Okay. So don't spend some time like that. Okay. Now, t d square t by dx square. You remember this? You remember this? Okay. Let remember this. T d square t by dx. Write this down. Write this down. Yes. Yes. Good enough. Good enough. Good enough. Write this. T d square t by dx square is half d square t square dx square minus d of t x whole square. Fine. Now tell me. Done? Okay. Now tell me. So what will happen? What is important? T d square t by dx square is equal to minus q by c1. Right. Now what this would be equal to? Tell me. T this would be d square t square by dx square into 1 by 2 minus dx dt by dx the whole square is equal to minus q by c1. Now we can integrate this, correct? Integrating, we can write half dt by dx minus integration of dt by dx the whole square dx. Will not touch it, let it be there, is equal to, this is c, not c1, c, is equal to minus q by c into x plus c1. Again integrating, we get half t of x plus minus double integration of dt by dx the whole square dx square, because two times you're doing dx square, okay, or dx is equal to minus q by c x square by 2 plus c1x plus c2. Fine. Now at x is equal to plus L, calculate c1 and c2, students, like this. X is equal to plus L half into t1, that is 600, correct, 600 minus integration of dt. Write this one till here, then we will continue in the next slide. Dx is equal to minus q by 2c, because it is 1 plus 1 plus c1, right, plus c2. Similarly, at x is equal to L is equal to minus 1, you get half into 600 minus integration, double integration dt by dx the whole square into dx is equal to minus q by 2c minus c1 plus c2. What you get the answer? Then it is simplified very much. Okay. We can cancel what we should add, or will add. But when you add, you have this additional one. You subtract so that this will go off. Okay. So when you subtract, you get c minus c1 as some number. What is that? minus C1 is equal to, this cancels, huh? You can get, is it not? Right? You get C1, huh? 2C1. Tell me. Oh, so C1 you will get it as 0. Fine. Uh, at at x C1 is equal to 0, at x is equal to 0, dt by dx is equal to 0. Fine. So now what you will have? You will have this as, yes, dt by dx is equal to 0. So what you will get? Half t dt by dx is equal to 0. This is 0. Then this is equal to minus q by 2c, q by 2c. C, what is C2? C2 value, what is it? Yeah, yeah, you can solve it. You can solve it. C2 you will get in terms of this. C2 you get some function of integration of dt by dx. Make sense? And then you get the C1 and C2, and there it is dt by dx is equal to 0. You get the t here. I'll do it. I'll do it fully. I'll do it fully. I got the point. I got the point. Very good. Very good. So until you put pen on paper, nothing will happen. What happened? So now, did you get? You're getting it? Oh no. We will do. Okay, write this till here. Write this till here. Yes. Constant, we are not. We are not worried about constant. Zero, integration of zero. What will you do? When you integrate, this is one of the main points which happens. When you integrate zero, you get zero only. Integration is addition. You add all zeros, you're going to get zero. You don't say integration of zero is a constant. No, 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 no. Integration of zero is zero only. Makes sense. Chalo. Now, here, do that, and you will get, by solving this, we get what is C1. Okay, right till here, right till here. What was C1? We'll see, we'll do that. We have not done it yet. We have not done it yet. Have you got the value of C2? No, right? C1 you say it is 0, we will see. Okay. So what happens? Let us say this is equation A, and let us say this is equation B. Now let us have equation 1 or A plus B. When you do A plus B, you get 600 plus 2 times or minus 2 times double integration of dt by dx the whole square into dx square is equal to, this can gets cancelled, sorry, this becomes plus, is it not? So you get minus q by 2c, q by c, q by c, okay, plus 2c2. So what you will get? C2 you will get it as 300 minus double integration of dt by dx the whole square dx square plus q by c. Fine. Correct. What is C1 you get? A minus B. What do you get that? A minus B, when you have C1 you will get a 0. Good. Write this till here. It's proper. It's proper. It's floppy. Exactly. This term will get cancelled. Goes on. So you put it, you will get it. From the first principles when you go, tough, tough, tough. Now, had you ignored that this one, then you wouldn't have got this. Good. It's small only. It's not very big. We don't have confidence in integration. That's why we did not go. Shailesh, enjoyed?
Sir, I think you have derived one equation, no, sir, heat conduction equation, 3 dimension.
Ah,
I think if you would have derived the same equation for 1 dimension, we
hmm.
would have got this easily, sir. I mean, like d square t by dx square is equal to minus q by k. That k came below because we have taken it as a constant from d by dx of k into d by dx of. I hope you understood what I meant. If you go to the derivation, I'm just checking the derivation. I think that is more simpler.
No, we have to get simpler one.
Not this one. Yeah, there only, I guess. Yeah, see, if now in that last equation, minus at the right hand side, last end, dou by dou x minus k into that equation.
Yes.
This is for 2D. This is for 2D, no? I mean, x and
Correct.
y direction.
Correct.
If you would have solved the similar kind of thing for 1 dimension,
Hmm.
I think it should have been like d by dx of k into dou y, I mean, dou t by dou x into dx.
That will
Dou y
come
and
as
dou
same
z.
thing, is it not? You will get dou square t by dou h square. You will get k. You cannot take it as a constant.
Yeah. So from there only got the answer, no? So c into t.
K cannot be taken outside.
Yeah. So from this one you could have got the answer easily.
K you cannot take outside means the sense that K is a function of temperature, is it not?
Yeah, correct.
So
Like
dou
in
by
this,
dou x, okay, dou by dou x of you have yeah. He's a very good student. This is good. So minus K, which is K is C into T into dt by dx into dx. Okay, now dt by dx into dx. Now you can differentiate this. I will come back to that, Shailish. Let us solve this. Is right on that point. Is right from on that point. Okay. Let us look at it later. Okay. We can start from there also. Okay. So let us do this first. Let us do this first and get the answer. Do we get the answer? We'll see. Or is there a simpler method? We'll see. Today one problem only in the whole class, but it's okay. Yes. Done. Got the answer. Got the answer, dear. Please solve it first. 1,000 only. Don't get the answer. Good. Kelvin square. Kelvin square. Kelvin square. Pa. So there's a mistake there. You don't get the answer. What's the answer you got? 1,000. Okay, let us done the you did the calculation properly. Do it now. Yeah. You say equation does not match. How come? Q is what? Q is in watt meter square. This is watt per meter meter. This is watt per meter cube. This is watt per meter Kelvin square. Okay, let us use another one. Let us use another one. Okay, watt per meter Kelvin square it is. ಶೈಲೇಶ ನಿನ್ನ ಮೆಥಡ್ ಅಲ್ಲಿ ಮಾಡಿ ನೋಡಪ್ಪ ಮಾರ್ಯ ಬರ್ತದ ನೋಡ
ಹಾಂ ಸರ್ ಟ್ರೈ ಮಾಡ್ತದೆ.
ಮಾಡಿ ಮಾಡಿ. See, all these techniques, although we have failed here, okay, to get the right answer, the techniques, the struggle what we have had will help us. Will help us in getting better. We got some techniques of solving differential equations. You saw that? $700 is not the answer. 1,000 is the answer. We are wandering there. It's okay. We will solve it in the next class. It's okay. We will stop it here.